You're DevOps engineers now, 20 years of 1 year experience. Serverless for everything. Kubernetes has been boring for 6, 7 years. I like silos. I see a lot of people that are like senior engineers and junior humans. And so when I hear this AI world,
Hey everyone, today we are going to talk about DevOps with a pure legend, Kelsey Hightower. It's me, Ruslan, and Ernst from JetBrains. We are sitting in JetBrains office. Hey Kelsey, you are the person who shaped the vision and engineering skills of so many people who were doing infrastructure, automation, cloud-native systems. Great to have you here.
great to be here. I don't know whether to be honored by that or should I apologize for, influencing so many people.
Definitely honored. So let's start. The first question, we're not going to talk about the past of DevOps. Let's talk about DevOps in 2025. I do even feel a little bit weird because we've been talking about that so long. But some people say that DevOps actually is in a dead end because the original idea, the original manifesto, the original concept was about making collaboration across all the software development lifecycle, right? But what we ended up with another siloed DevOps team, and some say DevOps engineer, right? Running around the pipeline, punching other people to collaborate. So how do you think, do we still have chances to bring the original DevOps idea back to life?
What we ended up with was a blueprint. Doesn't mean you had to follow it. And I think that blueprint was kind of built on the backs of people realizing that just managing a server wasn't enough, especially if your team was going from 1 server to 300 servers. Shell scripts became production components. Our syncing files around were part of the whole stack. And so we needed people to evolve. And some people did evolve. I think people kind of get confused about, did the title come first or did the work come first? And so I think what we did was we practiced quite a bit. There's a lot of people who were crossing their particular skill set to maybe help the team in a different way. So if you were a system administrator, like me, you learned to code. If you learned to code, then you learn how to integrate the application with the infrastructure. And then we got this new name. We got this thing called DevOps. And so that blueprint, this idea, it was always there. We formalized it with this new vocabulary, but it doesn't mean people followed it because I think DevOps wasn't enough. DevOps doesn't necessarily say you're required to have discipline. You're required to learn forever. You're required to hit a road bump and say, how do we solve this? And maybe I have to learn new skills to get there. And so I think this is where it tends to run out of steam. Some companies took the easy route. Hey, you're no longer system administrators.
Oh, yeah.
You're DevOps engineers now. It's like, oh, wow, do I get a t-shirt? And so some people just put on the t-shirt and they didn't change anything else. And this is where after 5 years of just pretending to do something different, and then you look at the results, you find out that the words DevOps don't mean anything on their own.
Yeah, so you actually need to wear not a t-shirt, but a hat, right?
Or focus on activities versus impact. That's like the biggest part of this whole thing. So when I hear DevOps, what I'm hearing is whatever specialization you have, that's just the starting point. If you're a developer, maybe you can assist in making better log messages so that the observability team has a better chance at actually identifying real errors versus the one you tell them to ignore. If you're a system administrator and you're really good at Linux, then how do we get the most out of a Linux server for the app we're actually running? So that means you may have to learn about the JVM. And if you do this well, then the results will be less memory usage because you've learned to tune the JVM based on the kernel that you have. So to me, it's that fundamental thing. Whatever name you want to give it,
of course,
works for me.
Yeah, okay, cool, thank you. So basically, but apart from the culture thing and learning thing, I do think there is a tooling part too. And that's where the platform engineering thing comes from. Do you think the platform engineering is some kind of evolution of the DevOps ideas, or this is like something new that pops up just coming from the developer productivity scope or view?
So you think about those two words, dev and ops. I think a lot of people were familiar with the ops component.
Yeah.
The server is broken, I will fix it. I will wear this pager and I will be on call. And if anything breaks, I will fix it. And people did that. And so there's this expression, some people have 20 years of 1 year experience. That means they kept doing that over and over again. They even got promoted to senior system administrator because they answer on call much faster than the junior administrators do. But then there was this call for action of, we have to take what we're learning and actually put it into the tooling.
Yeah.
So instead of having some build guide or a run book, can we not serialize all of that expertise? It could be a shell script. And I think this also coincides around the world of configuration management. Let's take all of these best practices, all of these system tunings and tweaks that we've found out from all the outages in production. And once we started getting tools like Puppet, Chef, Ansible, can't forget about CF Engine, we finally had a dialect that was something that we could articulate what system administrators do. We can actually finally declare what these systems should look like. So I think DevOps was this idea that we should go beyond the ad hoc nature of the work and turn them into actual tools, which brings us to like the platform engineering.
Yeah.
And this is the biggest challenge I think we have from this group of people. If your world is just keeping the lights on, you may have no idea how to design a better light bulb or what value a light shade will have to the equation. So what we're asking people on the platform engineering side is to move beyond the thinking of automation and just tools. We're really asking them to design APIs. I'm going to give you an example. In the DevOps world, you'll get a nice badge on LinkedIn if you did this. Use Terraform, teach everyone in the company HCL, checking your Terraform, build a bunch of DevOps pipelines, and you can consider yourself a DevOps engineer. So then what's the difference between that and a platform engineer? As someone who spent 8 years in cloud, you can't stop with HCL. That is an insufficient API to talk about the contract. And I was at a conference recently and I had an engineer who's like, Kelsey, I'm trying to understand how to make the shift. I said, I'm going to walk you through it. Right now, you think the goal is to teach the whole company Kubernetes, Prometheus, Docker, Terraform, right? That's what you think the goal is. He's like, yeah, his eyes lit up. I was like, but then you would be wrong. If you had to do all the deployments for the entire company, what questions would you ask of the development team? Sit next to them and just think through it. He said, well, I would ask for the version. I would ask for memory and CPU requirements, maybe how much disk space they need, and maybe what region it should run in. I was like, is that all you would ask? He's like, yeah, I think that's all that I would ask. And I was like, that's your API.
Yeah.
You turn that into an API. It could be a simple YAML file in the repository. It could be an API endpoint that they call with curl. But that's what the company wants you to do. They want you to take whatever platform you've inherited, VMware, or the cloud provider, doesn't matter. And the glue between what the vendor provides and the API we just talked through, that's what you're supposed to deliver as a platform engineer. And then whether you're using Kubernetes or Terraform is an implementation detail. And right then, right there is when the light bulb went off for him. It's like, I need to be building products.
Yeah, I see. Well, I feel the same completely. Thank you for this opinion. So now I just want to pass the word to Ernst.
Yeah, so you already mentioned that like Linux systemization skills are very important, and that we're seeing that platform engineers should create this API between the needs of the company and the hardware that's actually running it. A trend that we've heard about recently is about a lot of companies rethinking their cloud strategy and thinking more and more about repatriating onto on-prem hardware. Have you seen this so far?
Yeah, I've seen it. I mean, I think 36 Signals was a good example. They went through every major cloud provider. So these are the company behind Rails, so very strong engineering team, so much so that they've codified their way of building web applications and called it Ruby on Rails, and it became a framework for a lot of people trying to build three-tier architectures, 15, 20 years ago. And so the same group of people also bought into the cloud, right? They were a GCP customer at some point, Amazon, Microsoft Azure. And the challenge with that is the cloud isn't for everybody. And like a talented team like that, they can probably make any platform work. But in their world, they were able to benefit from their expertise and they can run it themselves. But I think what most people have struggled with was a concept of believing that you could rub cloud on your mess and it will somehow be better. And so what some people did is they didn't change anything. They still leave everything on. They still provision machines that are way too big because no one either has the tools or the skill set to actually do real performance analysis to figure out how much memory CPU do you actually need. So what they ended up doing was just lifting and shifting everything into the cloud. The problem with that, there's like a 2 to 3x premium to run in the cloud. It is a premium offering over buying a bunch of servers and running it yourself. So for those people, it was a huge penalty for their old behavior. And so after about 5 years of doing this, a lot of people are scratching their head and said, oh, we were not willing to change our operational model, and we can't afford this tax. And on a positive note, a lot of hardware has gotten really fast and really big, and the prices have come down in some areas, and also the cloud has evolved. We went from proprietary systems like EC2 and S3 to open services like Kubernetes and Prometheus. So you finally actually have a chance to get that cloud-like API on-prem, so I'm not surprised people are trying it.
Okay, talking about technologies that were very popular in the cloud. A couple years ago, serverless really seemed like one of the big things that was taking off, where a lot of organizations were investing into doing things that way around. Where do you think that trend is these days?
So when serverless came out, I was deep in the container world, like Docker. I'm coming from configuration management. I was an engineer at Puppet Labs. Then I spent some time at CoreOS. And we think we kind of figured it out. We finally figured out the difference between automation, which was the DevOps movement, Puppet Chef and Ansible, and abstraction, which was Docker. And for many people, they got rid of a lot of those tools in favor of a better set of abstractions and workflows. But there was still this server there. And for us, that represented power. We were like, yeah, that's exactly what we want. We want choice. We can go to any cloud provider, or we can even run it on our own laptop. And the serverless paradigm, at least when it was introduced, was like this function. So if you start there with this function signature, there was this idea that you really didn't need an entire application because all you're doing is processing some data. And ideally, that may be the only architecture you need. What I think gets missing from this story, that works when you already have EC2, when you already have 5 other compute platforms where serverless is just an option. So some people got really excited, and they were like, serverless for everything. And they just started converting things that had no business being serverless, but I think the idea was right. Can we decouple so much from the machine that we can make it go away or give the illusion that it's gone? Mm-hmm. And so that event model of just implement your handler. But I think what we've learned over time, though, was languages come and go, frameworks come and go. And by the time you start to implement every language and framework, it's unmaintainable, especially for the platform provider, your cloud provider in this case. So what we ended up saying over time, if you wrote any serverless code, that little function signature that looked really great for Hello World, by the time you imported a database and all the other things, that HTTP handler became function main. And then it just got as big as everything else, and people were coming up with all these serverless patterns. And I think the world kind of realized, like, stop. I tend to think about serverless as a framework, just like Ruby on Rails is a framework. If you buy into the framework, you can get a lot of benefits from it. But if you have to break out, then you're kind of stuck. And maybe another paradigm is for you. So I think where we are with serverless is, I think containers are still one, the container image. Mm-hmm. Put your thing in there. And if it's a Lambda contract you want, then you can use the Lambda shim. If it's a Linux kernel contract you want, then we all know how to bind to a port and wait for traffic. But this image that allows us to go from Heroku to a VM to Kubernetes in between, I think that was a good kind of place where we landed in the middle. Platform independence, pick the one that gives you the most value.
Okay, so if I would summarize your answer, serverless is a great idea, but if you start using it for everything, you're abusing the concept.
Yeah, I think workload APIs. I think the thing that was exciting about Kubernetes, it really highlighted there will be more than one workload API. So if you think about the original workload API for some people, it's a server. I have a shell, I can SSH, there's a bunch of utilities on user bin, I could use those if I want to be a good developer. You don't shell out, you use a library instead. And for some people, that is the original platform. And then you start thinking about the workload API. What's a web app, right? So then I remember JBoss and Tomcat. It's like web apps have a certain structure, just use an application server. And then for some people, that became the platform. In the cloud, we zoom out. And when Kubernetes arrived, that was the very first time I seen us give a type system to what a workload is. A deployment is this. It's identified by the structure. A load balancer is this, and it can point to one of those. And then we all realize that, okay, so we have web apps, we have cron jobs, we have batch jobs, we have ML workloads, we have serverless workloads. This is never going to stop, but what we've learned is that we should express those workloads with intent, and then we can give them whatever name we want. This is serverless, this is a VM, but we still want this object model that allows us to actually share these concepts around. So I think we're at the point now where distributed systems are probably here to stay. We just want to interact with them via workload APIs.
Excellent. And so if we then already are talking about Kubernetes, frequently people say that you should build your applications on boring technology, where boring technology is technology that doesn't excite because it just works. It just does the thing that it needs to be doing. For example, I think with Go, we've kind of reached a point where Go just works, and therefore it's become boring in that sense. Do you think Kubernetes has reached the same point?
I think Kubernetes was born a long time ago, but it has a very friendly, extensible system. So you can make Kubernetes as exciting as you want. If you want Kubernetes to be a network traffic management tool, you can build a service mesh on top. And when all your traffic stops flowing, it will be very exciting when you see new alerts and errors you've never seen before. And so I think the fact that if you have a stateless web app, Kubernetes has been boring for 6-7 years. The thing that makes people interesting is people are trying to use this orchestration engine that requires you to fill in the gaps on its original designs. So if you want Kubernetes to manage a database, something like Postgres or MySQL, where you're going to have to build that control loop, and people are very excited about this because, number one, most people don't know how to do it. The people that have tried it occasionally lose data from time to time. And so you always know that it's not where stateless apps are. And so we know that there's a gap between where we are today, and it's been much better over the last 5 years, so credit to anyone working on this. Mm-hmm. But there's a lot more work to do, and that's when things become so exciting. We know that if we actually complete this, you might be able to run a database at scale using something like Kubernetes. So until then, it's going to be really exciting, but you're right. I think infrastructure is only exciting when you think about it, right? Planes are only exciting when they don't do what we expect them to do, right? Once you land, you get off the plane, you don't think about it. It's only when you get turbulence. I was on a flight a couple of days ago. We landed and everyone started clapping. It's like, oh, something must have gone wrong that it deserves our applause when you land, right? We just want to get off the plane and not notice that anything has gone wrong.
Or these were the people who don't fly frequently, right? So it's some kind of exciting about flying. Because like each time I try to take a look at Kubernetes, it's still exciting for me because like I'm okay, what's happening here? But yeah.
But like the plane, you want the place where you're going to be the most exciting part of the whole thing, right? Maybe you're going on vacation. You want that part to be exciting. Yeah. So for people, it's like the things you can run on Kubernetes. We want that to be exciting. Yes. But when the infrastructure gets in your way, it's usually not described as excitement. It's more like friction and frustration. Mm-hmm. And maybe we get excited when we finally get that to work, right? But that's not the type of excitement we want at the infrastructure level.
So if we're talking about excitement and where we're going, you once said that if we're still talking about Kubernetes in 20 years, then that would be a sad day because we didn't come up with something better. Are you seeing anything on the horizon yet that may be the better thing to replace Kubernetes one day?
Yeah, and sometimes I think of it as much deeper as if we're still using Kubernetes in 20 or 30 years, we didn't come up with anything better. And there's nothing necessarily wrong with Kubernetes, but before Kubernetes, we thought maybe Docker was the end game. And then one day Kubernetes shows up. And so I'm hoping that progress will continue. Maybe we learn a lot from this Kubernetes era that something should show up and replace it. And people always ask, like, what would come and replace it? So to me, Kubernetes is an implementation detail. It's kind of proven out to be a generic, almost Ruby Rails-like thing for infrastructure that says you can design your own workload APIs on top, and the control loops will just make things happen, like the original promise theory. But then when you think about the implementation of Kubernetes, do you need it 30 years from now? Why not just have a different implementation that's a little bit closer to the machine? Mainframes come to mind, things that are fully integrated. You see this in some AI ML workloads where the infrastructure is the model itself. The GPU you're using, the network cables between these things become front and center now because the current infrastructure just is no match for that particular workload. So in that world, do you really need Kubernetes as currently implemented? Maybe we get a new type of machine in the future that doesn't need what Kubernetes actually does. But I think on the surface, there'll be a very similar thing that looks very familiar, the concept of a workload API, where I can just describe my workload, and whatever comes in the future, whether it's Kubernetes or not, should ideally take one of these things and just make it work.
I fear that if we're talking about a future where we're describing workloads, this may involve some AI over there, where he may be describing what he wants to an LLM.
Can I pull on that thread really quickly?
Sure.
Because my whole career, and maybe I'm just outdated, my whole career, the whole point of our profession was to take this non-deterministic thing and make it predictable.
Yeah.
When it's not predictable, we call those security incidents or bugs. So we work really, really hard. We even write unit tests to make sure that the system behaves only as intended and nothing else.
Yeah.
And so when I hear this AI world, I'm always asking myself, why predict when you can know? And you still want to build these kind of rigid state machines, maybe the tools that help us generate these state machines, sure. But just like databases of old, I remember when SQL queries were expensive to run. You ran a query, it could take all the CPU on the server, and you could only run so many in parallel. And when that happened, we brought out caches. Why run the same SQL query twice when you can cache the results for other requests? And we got a huge performance boost on that. When I think about this type of infrastructure, just like all things in computing, maybe we use AI to assist us in building these things and research and discover new methods and patterns. But typically, once we learn how something should work, we try to build a static state machine that is highly predictable, very efficient to run. If we're really interested, we'll see what we did in network switching. You take all of this logic and you burn it into the hardware so that packing switching is fast. You don't even do it in user space anymore. And so I don't see a world where the laws of computing change because we have a thing in the middle that can generate the same code over and over again. It's just, we don't even do that today. We have libraries and frameworks for a reason.
Exactly.
And so I think that's also something where in your previous interviews you talked a lot about AI, where there is a lot of hype around it, and you get these ideas where, like you're saying, we can be reinventing the wheel over and over again. Where can we see some real value between the hype?
So I'm going to try to be positive. I'm going to try to be positive about AI. When I think about the current toolings, just if we're focused on this DevOps conversation, infrastructure conversation, right now we have HCL, the Kubernetes API, Helm charts, SQL statements, various TOML, JSON, XML config files. Sorry for all my Java developers out there, POM XML. It's a mile long, it can be. In that world, there is no cohesiveness. There is no cohesiveness between all of these systems if you really want them to work. And you would have to glue together another layer that may or may not actually represent what's underneath. And these systems are very fragile, and they take a lot of domain knowledge. And this is the API we've chosen to stop with in our field. When I see people get excited about LLMs in particular, this concept where you can ask for what you want, deploy this app to this region, and allow traffic to it. Okay, that's how we start these things. And then as humans, we have to then take that and try to understand every other tool in the chain to make this go. And so when I think about intent-based APIs, that's what we want. Mm-hmm. And I think people are getting a taste of it with LLMs, where I can have this free-form API that allows me to express my intent and maybe have a nice feedback loop and say, is this what you meant? But under the hood, though, I make no illusions. It's still the same target outputs. There's still probably Terraform underneath, or maybe Terraform is gone in this equation. But you still have to call the cloud provider. And that app is still going to run under the same kernel, it's still going to allocate memory, and it's still going to write logs. So unless all that changes, what we're really talking about is a new API to do the things that we've been doing for the last 30 years. So I can see why people are excited about this potential, but then, I can't resist. When I ask people to show me their prompts and their spec-driven development, and it's like 500 markdown files, a bunch of prompts. I'm like, what do you do with all these markdown files? And they said, well, we check them in. It's like, do you version them? It's like, oh yeah, we versioned them. Yes. We're starting to write tests for them as well. I was like, I think you may have created another programming language. It's like, oh no, you don't. And then they pause. Yeah, we're still trying to capture intent in a way that can be transferred from human to machine. So we'll decide if this is the new dialect that we want, but I got a feeling for those that understand the basics and the fundamentals, it may give them some creativity that maybe we can improve the current tooling to be a little bit more cohesive and have more intent-based APIs versus modular APIs that have to be constructed over and over again.
Yeah, now like it looks like now everyone is a DSL author, right? So everyone builds their own DSL to talk to an LLM, and then LLM talks to everyone else in the room.
I mean, hopefully it works as good as those domain-specific languages have worked in the past, all right? And now, right now, I think a lot of people are, it's exciting again. Like, I don't know what it's going to do.
Yeah, that's the point. You actually get a little pinch of indeterministic behavior, even if your DSL is perfect, right?
And we're seeing a lot of work where people are now trying to, and it's funny that they don't even use these words, deterministic, safe, repeatable, reliable. Once you start to add those back into the equation, I think they call them guardrails now, right? They say things like guardrails and alignment and tuning and all of these things. But I think we end up in the same spot where the goal is to build a reliable system that works as intended and only as intended. And if this is the path that some people choose, then so be it. But I think they're screaming for a better API to express what they want. And hopefully we don't have to write code across so many systems anymore.
Yeah, so we're definitely talking about how AI can be something that helps take an intent and turn it into the requirements to this deterministic system that you mentioned. So if the AI is there, where do you think are places where the humans are really irreplaceable?
I think one important part on the AI front that I think a lot of people forget, I wish we had the same level of docs people have committed to write for the LLMs. I wish we had the same APIs across all these black boxes we had in the past, because the MCP hype has now inspired these traditional SaaS vendors to finally give us an API. Because if we've had well-documented APIs for everything like Google Calendar, Google Docs, Salesforce, imagine you could probably just use Bash and curl to build any pipeline you want. But since we didn't have APIs into those systems, they were just black boxes. We were all just screen scraping. So I'm surprised that for real intelligence, you and I, that we didn't do all of this work for. And now for artificial intelligence, that requires this work to get to where we are and what our capabilities are. So I'm hoping that people realize that this was always a requirement. Having APIs for everything, well-maintained documentation for everything, prompts and hints go a long way for real intelligence as well. So I think that is a thing that if none of this works out and all we're left with is APIs that were never there before and a bunch of documentation that was never there before. I remember trying to get a developer to describe their system that they built was like pulling teeth. Now it's the thing that they have to do in order to get the machine to do anything for them. Man, hopefully that discipline sticks around. So I just want to have that quick little detour because I think that part is so important, that this work we're doing now was always required.
You're so right about that. Like, it makes it so much easier to work with systems if it's all well documented. And of course, MCP is in essence an API that requires extra documentation. So in this world where everything is much better documented and it becomes much easier to pick up these new systems and work with them, do you think that with these AI capabilities and the changes we're seeing because of AI, we could see a revival of the original DevOps vision where there's more shift left of ops going to development teams?
I hope not. I hope not. Because I can remember when I was a pure system administrator, I took a lot of pride in not just learning how Linux works, how networking works. I had a responsibility to prevent anyone else from having to do the same. That was my part of the equation. And then the other part of the equation was like, how do I maximize the utility out of this system? I mean, I remember the first time I realized that I could use RPMs for even the custom apps we were building, and then allow the team to actually benefit a bit more from the underlying OSs that we were running versus them cooking up their own package management and software deployment systems. And I also been a full-time developer before, and I know what that feels like. You're trying to understand the problem so well that you can translate it into a syntax that then the compiler will turn into machine code, and you're crossing your fingers that all the libraries that you've imported do work as intended with no hidden bugs. And the moment you check in that code and you say it's destined for production, every developer that I know that cared about their work, always in the back of their mind for the next couple of weeks, you were always concerned, is that thing going to hold up? Is it going to actually be able to handle all of our traffic? And if it doesn't, it's on me to fix it because I'm the only one here that has the context. I've made all these decisions to use these libraries. I don't have time to worry about Terraform and keeping track of all the cloud provider APIs. I almost want you to hold up your end of the bargain so I can hold up my end of the bargain. And going back to kind of this original DevOps discussion, I used to get in trouble. It's like, I like silos. They're like, oh, no, Kelsey, we cannot have silos. That is not a good team environment. I was like, I don't believe you because when I go to the airport, I don't know how to fly a plane. I don't know how to run an airline. I buy my ticket, really great API. I purchase my ticket. I show up. I sit in my assigned seat. I close my eyes. I wake up and I'm in a new country and I leave. I might tell the pilot thanks for the flight, but no other interaction is required to do something as routine as fly from one place to another. And so in my view, if I'm going to own the infrastructure, I want to be that kind of team player that says, software development is hard on its own. What contract do we need to make sure that whatever you build gets into front of the customer in the most efficient way as possible? I'm going to be an expert in this domain, you'll be an expert in your domain, and we'll meet in the middle. Not by sitting next to each other, but hopefully by a well-documented API. And when people scratch their heads like, hey, Kelsey, I've never seen this before. It's like, what do you think the cloud providers are doing? Most people have never met the back-end engineers on S3 or the load balancer offering across cloud providers, but somehow you're able to use all of that stuff without necessarily interacting with them every day. And the last thing here is I don't want that to sound like you don't talk to each other. We should only talk to each other when necessary, like we need a new feature. We need to evolve the API, and it requires us to collaborate to get to the right destination. But once the API is in place, we don't need to collaborate on how to launch software to our customers for the 1,000th time this week.
So yeah, as you were saying before, as a platform engineer, the role is you figure out what that API is, and then at that point you specialize. Like the software team builds great software, the platform team builds a great platform, and the APIs, how they work together.
Yeah, so we're back to silos now, right? And I totally agree about this domain knowledge thing, because like each time you talk to people who hold domain knowledge, it's you can't know everything, right? So we don't expect everyone to know everything, and I'm totally agree here. And this is the thing I just wanted to ask next. So given the current fragmentation of the developer tooling on the whole software development lifecycle, so we have right, we are writing code, we are like testing code, we are deploying code, before that we are building code, then we deploy it, monitor, observe, blah blah blah. And each stage has like dozens of tools listed, and they are all great. So we have so many things. So do you think there is a realistic path towards a future like where something single can actually wrap all this complexity for people sitting on a pipeline, not to have 6 monitors to see everything what's going on, but wrapped around it, vendor lock free, I don't know, functional enough, smart enough, and I'm not talking about artificial intelligence. I'm here more, I mean more, this deterministic heuristics, which we all know. So smart enough tool that allows one single person have one single screen and actually embrace this whole complexity.
I mean, it's a tough one because it's like saying, why do we have so many spoken languages around the world? And if I just take English as an example, there are so many words. Do we really need them all? But without those words, then we limit the way people express themselves. And sometimes new words appear because someone chose to express themselves in a new way. And the way that they've put it on the screen in a movie theater, in a book you read, or maybe it's something they say just in the moment, becomes a cultural phenomenon. And now we have a new word to express ourselves. I don't see humans ever reducing the canvas of expression. And programming languages and configuration, they're also the result of that, right? Everyone could just be using MySQL. But then people say, well, there's got to be a different way. And we have the freedom to try different ways. We see this in food, we see this in fashion. I think that's just part of how humans are conditioned. We express ourselves. And it's also part of like being free. I'm not limited by this thing. If I find a new way of doing it, I can create and build new tools. So we have hammers and screwdrivers. And I think that should probably continue. I think though, as being a professional, you choose the tools you need for the purpose. And it's so hard because this is where discipline's required. And today, right now today, you can build a company worthy of going IPO, probably with a single Linux server, a Golang monolith, and pick one JavaScript framework. You could probably build GitHub. Right? Remember, GitHub gets acquired as a multi-billion-dollar valuation in that stage. Snapchat goes IPO using App Engine only. And so I think people forget that just because there's a lot of choice doesn't mean you have to choose them all. And so having this choice, it's just like when I like to do a lot of DIY projects at home. And when you go to the hardware store, there's so many aisles of tools. And you got to be disciplined when you're walking down the aisles. Like, I don't need to go down that aisle. I don't need that tool. Even though it's on sale, I don't need another screwdriver. I have 6 already. And so I think the same discipline is required, but the moment you do get a task, then you revisit the problem domain, right? There's one way that I'm familiar of doing things, but then you see a new tool that was purpose-built for that scenario. And it's not just the tool either, it's the education component. When you see someone else using that tool, it's like, oh, I didn't know there was a better way of completing this particular task. So depending on your situation, it may be worth buying that specialized tool. Maybe you're a contractor that does this as a professional versus someone doing DIY, you have to do this task once. So I hope we don't lose the creative side of it, but I do hope we remind ourselves that we're supposed to be professionals. So instead of you breaking away from everything being written in Java, it's working for your company, you just really want to write Rust for no obvious reason other than to satisfy your curiosity, that may be a mistake in the professional sense. So I think there's a way to do it now. The answer is yes, but you need way more discipline than curiosity.
Yeah, but I just want to step back and go to the metaphor. So basically, on my personal experience, you end up having a screwdriver, a whole bunch of special machines. So in the end, you want them to be stored in something like a toolbox. So basically, I'm not speaking about choosing one single tool for everything to build everything, but because like you always end up with you just cut the SDLC into 10 steps or like depending on the complexity of your software, you will end up with a set of tools. And sometimes you just want one single place you store them, like a toolbox, because like if I have a leaking deck, I take my toolbox and I will be able to take what I need from there. So that's kind of...
But there's no guarantee you can predict every problem you will encounter to build a perfect tool bag on day one.
That's correct.
Our tool bag evolves with experience. So yeah, you may be able to build a company with just Java alone. And then one day the iPhone comes out and they say we will never support Java. Now you find yourself learning Objective-C. Your tool bag has gotten bigger due to circumstance. So now you learn Java and Objective-C. And so maybe you just do back-end stuff, but now you have to learn front-end. And now you're learning things like SwiftKit and SwiftUI, right, out of circumstance. So I think for us is, can we be intentional about the way our tool bag evolves? I think you also speak to the situation where people don't even know what's in the tool bag. You have so many tools buried in there that some people go buy the same tool again. And you go home and you, oh my God, I already have this tool. I just couldn't find it. And so instead of looking for the right tool, you went and bought another one. And so I think sometimes this happens when we're a little bit too fast. And in the software world, it's so cheap to bring in a new tool. We don't even have to drive to the store. You can just go to GitHub, you see this library, like LeftPad. It's like, I'll just bring in this library when I could easily write those 2 or 3 lines of code. I think as a professional, that's what we have to be careful of. So when you see a professional unload the truck, one thing that they tend to do is clean off the tools. They look for damaged tools to see if they need to be replaced so they can be ready the next time they need them. They may even go and get some training on this tool, like, am I really effective with this hammer? Am I using it right or incorrectly? So some people don't even know how to use their tools completely. I've seen people like, you've probably seen this, you were at JetBrains, people have got this powerful IDE, and they use it like Vim. It's like, you know there's a debugger built in. You can actually call network calls here. You don't have to, why are you using curl in this case? It's built in. So I think that's also part of making sure your tool bag and understanding how to use the tools.
Yeah, I mean, I had a conversation with a person who said, like, I'm using this code because they have a nice Docker plugin. And I'm like, what's wrong with Golang then? He's like, does Golang have Docker plugin? I'm like, no, it's built in. So this is the exactly situation when you're saying, like, I'm going to buy a screwdriver because the screwdriver in my toolbox was on the second layer.
But I think that's just when, again, being a professional and a practitioner and not just a tinker, not just someone doing hobby projects. These are professional settings. And so some days you just have to, on your day off, you just have to look at my toolbox and reevaluate. And not a lot of people do that. We're just responding to the next issue, the next feature, the next delivery date. I like those situations where you just take a step back, breathe a little bit, and say, do I have the right tools in my toolbox? This one we never use anymore. Is it safe to remove this from the toolbox? Do we all agree that no one needs this particular tool? That's just a thing, I think, just discipline and just going back and reevaluating from time to time.
Yeah, I get it. And let's move further. Let's talk about people, because we've already started talking about people, right? How they use their tools. But the second thing is how people work with other people. So, because you are known to highlight empathy and communication as critical skills for engineers. So, what would you advise to modern teams to cultivate, to strengthen these non-technical skills of communication, actually?
One thing I realized, and sometimes I think about it, I didn't get into tech until the last year of high school. So before tech, I played 3 sports. I ran track, I played basketball, played football. And in most sports, especially track, it's just you versus the entire field. And in those situations, you win alone and you lose alone. But when you play sports like football, American football, and basketball, it's a team sport. I don't care how good you are. You need the rest of the team to handle their responsibilities as well. And so then you learn to win together and lose together. You learn that people are counting on you. You learn that some people have weaknesses and strengths. And a leader on those type of teams, you learn how to play to those strengths. You don't talk bad about your teammates. You're literally on the same team. And then you also know that you have to improve on your own time. It's not enough just to come to practice. As the game evolves, so must you. And I've never made it to the pros, but if you look at those scenarios, there's a constant competition occurring. There's a next generation of people willing to come and do your job better, and they help evolve the game. And so by the time I got into the technology world, I didn't realize I've developed very well as a human being, as a person, all the awkwardness of dealing with society. You're playing a game in front of lots of people. You can't hide behind it. There's stats. They're taking records of these things. Even just human interactions of just like having friends, dealing with, I wanted to like read comic books and play Magic the Gathering while balancing being an athlete that's supposed to be cool and dealing with the popular kids. And so all of this development I took into the world of technology. And when I got into tech, it was from survival. I didn't go to college. I was working fast food jobs. And if you would have asked me when I was 18, what would I be doing? I don't know, maybe being a manager at McDonald's. And there's nothing wrong with that kind of job. I just didn't even know that this type of world was possible. I didn't think that I could ever live in a world where I wasn't operating in a read-only mode. In read-only mode, you do what's in front of you. In this world, we create things. And so for someone who gets into this world out of pure survival, I just want a good job that pays well, that has plenty of room to growth. And I can't even imagine the things you could do, but I see them on TV. So when I get into tech, I'm just so excited about the opportunity that maybe I don't have the same base case of just being in the enterprise where you follow the corporate politics. When they tell you no, you fall back. When the vendor tells you no, you fall back. And so I've always looked at it as this team sport that is still on me to be the very best player so that my teammates can count on me. And when we win together and we lose together, but the season just repeats itself. It's never over. It's never finished until you give up. And so when I think about it, I'm very fortunate to have developed as a person. I see a lot of people that are like senior engineers and junior humans, and they can't tell the difference because they prioritize the work environment over reality. And so when I think about software and this team aspect of it, I think that's the part that's missing. And so when I think about AI, right, so this idea that I come from a world where I'm thinking that the humans lived and done things, and we've created the data set. So we used to train each other. Now we figured out how to take the same data and use it to train the machines. And that's amazing. But typically when we trained each other, they just became a teammate and we worked side by side. And the thing that kind of makes me worried about where the industry is headed, sometimes you hear less conversation about the people, right? Maybe the customers because they provide the revenue, but we don't talk as much about the teammate, the human, the other person, as almost if we don't need any more lived experiences that then translate to data that improves the data set over time. It's almost like people believe that we can checkpoint right here. 2025, we've built enough systems, we've built enough software, we've operated enough platforms. We can just stop here, draw the line, and just tune the model so they can take over from here. And that to me is against the very thing that brought me into this world, which is the ability to create. We will have new experiences, we will get new ideas, and we hope the whole palette of tools are available to us to bring them to life. So the human element is super important, and I can go on, and I think the last element for me was the open source component. So coming into this industry as a professional with a job, every company has its quirks, and many companies have its limitations, usually within their four walls. But it felt like the open source community is almost like you jump in where you fit in, you find the technology that you like because you like it, and when you're working with a group of volunteer professionals for the most case that share a vision and willing to do whatever it takes to make it happen, feels a lot like those sports days where we win together and we lose together.
That's quite a deep insight about the junior human and senior specialist. So if there is a friend of mine who would like to evolve as a human and he's not really into team sports, the question I would ask, do you think joining some open source project would actually help to make the step forward in this way?
Probably not necessarily, because when we say human, it's the things that you do when you close the laptop. And I think people forget that inspiration leads to probably more inspiration. So you get off of work, and instead of trying to figure out the next programming language, go watch a movie that inspires you. Go spend time with your family in a way that inspires you. And what I've found in my career, being inspired in that way and then coming back to my work with fresh eyes, that inspiration flows into the project. Maybe I want to write the best docs the team has ever seen. Maybe I want to fix that bug completely this time. Maybe I'm very excited, and then it just carries over through the work. But I also think you have to realize it. Like in work, we tend to get a lot of opportunities for assessment. You get one-on-ones with your manager. Maybe they give you feedback, how you're doing. You have OKRs. You look at those and maybe you review. You have promotion processes that you apply for. And so if you wanted to mimic some of those things, I have a daughter, she's 18 now, but you just have a conversation. Or I've been married for 19 years. How's it? Is there anything I can improve on? And you give an example, because that's not something people tend to talk about. Go check your credit score. Go review your retirement plan. You can ask yourself a question. Why am I working? Is it just to have a bunch of money? Is it to buy something? Is it to buy something that matters? And so I used to ask those questions. Who am I? Like in my profession, you say, what do you do for work? And you would say, I'm a system administrator. And you would say, are you a system administrator, or have you limited yourself to being a system administrator because they hired you as a system administrator? And that gets me back to that point I said earlier, 20 years of 1 year experience. And sometimes when people wear a title, they forget to evolve and say, how come you don't know anything about databases? Because I am a system administrator. But that doesn't preclude you from learning about a database. So at some point in my career, I said, hey, I'm just a technologist. And as weird as it sounds, as uncomfortable as it sounds, you are a human. It sounds so weird because there's nowhere on the job application where they ask, There's nowhere where people tend to measure these type of things in a reliable way and give us that kind of feedback because people aren't used to that feedback because you have to actually feel something. When you write code and it doesn't work, the compiler screams at you, but it's not a real thing, right? You just fix it and you just move on. You don't take it personal. But when people give you real feedback about who you are, wow, this requires work. And then to change that almost has to be admitting that there's maybe some things to be worked on. And not a lot of people have enough experience with that. So I think if you want to improve in this area, you have to go outside. And I think the things that are nice about open source communities is they tend to treat themselves as a community first. Things like conferences, communication is voluntary. There are no morning stand-ups that you're required to attend. So if you show up, you're volunteering to show up. And if you learn to respect people there, you know that they're doing this stuff on their free time. They're doing this because we share a common interest. And sometimes that's enough to kind of lower the barrier so we can all get to know each other. Meetups and conferences, we see each other in person. And we know that we're not going to be in that place for very long. And so we try to make the best of it. So what we don't do typically is whip out our laptops and start writing more code at the conference.
Yeah.
The conference is probably not the best place to write a bunch of code you can. It's probably the time where we go out to eat, we learn about each other. Oh, I've known you for 10 years online. I didn't know you had kids, right? It's that moment that we get to actually practice being a little bit more human.
Yeah, makes a lot of sense. Another thing you actually mentioned before was about like new people coming and, like embracing and teaching people. I guess this was when we've been discussing AI. So let me ask you a question about this way to enter the DevOps field, let's say so. Do you think the skill path still works? So probably, like if we step back and see how testing evolved, they sometimes, like with the movement of time, they actually decided that they don't want everyone to have a university degree. So they introduced a certification, like be it ISTQB or something like this. And it was enough that you can just take a relatively short but like full course, become a specialist, and then join the testing industry. Do you think something like a Kubernetes certification or learning course is possible to exist?
No matter where you start, you're going to end up in the same spot. So if you went to college in 1985, Kubernetes came out only 10 years ago, you're going to be forced to learn with the available resources. You can't just say, well, I'll wait till Kubernetes is taught in college, and I will go back and learn Kubernetes at university. That doesn't make sense. So I think all paths lead to self-learning, all of them. So for some people, now that we have a Kubernetes certification, maybe that's where you start because it's accessible. There's a guided path. I remember being part of the people or group of people who helped create that initial exam. And so you look at, so remember, there were Kubernetes quote unquote experts before the exam. Okay. And we all got together and we decided we think that these are the core competencies. And I think over time, companies have also put input in on what they would like to see from someone that is certified. But I am not Kubernetes certified, but I did write the book.
Yeah.
So I think that's just one element to this learning. But the part where you're a team member, and I hope the people listening to this understand what it means to be a team member. When you get a new hire, the best thing you can do is kind of make time for the new hire. Yep. Don't be so busy that week, or at least not everyone. You almost have to go and be willing to stand side by side and say, hey, welcome to the team. I know it's new here. You're going to have tons of questions, and don't worry, I'll be here to answer. So what does that look like? Maybe you work on a task together. Hey, I got this task that needs to be done. I've been saving it for you. Now that you're here, we will do this together. You have two choices. We can do this on your machine, or I can do this on my machine. Now, the benefits of doing this on your machine is that we're going to add all the things to your machine to get to the point where you can start working on your own, and you'll have someone next to you, and we have a shared outcome. I remember I was speaking at this university, and they have a computer science program that starts in the summer. And they do a group project where all the students' grade is determined by the lowest student's grade. Mm-hmm. So if there's 50 people in the class, the lowest grade of anyone is the grade of everyone. So now not only are you just going to have a group of 4, the group of 4 are checking on the other groups of 4. Hey, are you guys good over there? Is everybody good to go? Great, because we need everyone to get the highest grade possible, and it's your actual grade that is permanent. This is not like a fun thing that doesn't matter. And so everyone builds a cohort, and those cohorts then stick together. I went there and they had yearbooks. Hey, this is cohort number 13. And they stick together because they've learned to operate together. So I think this idea that as a team member, you almost have to believe that it's your responsibility for this person's success. Now, they have to do something as well, but there's nothing worse than seeing someone join the team and then leave the team before you've had a chance to help them be the best version of themselves.
So I think earlier we also discussed like how you need to keep on learning. This is something you need to keep on doing. On the one hand, there's individual skills that you can keep learning in various ways. How do you think people can keep learning these team skills, but in a way that they can develop them to become the senior human that we were talking about earlier?
So maybe I'll talk about how I learn my technical skills and then how I learn my human skills. So for technical skills, I have 25 years of experience. It's a long time. But I noticed a pattern. If a new thing comes out or if it's new to me, always ask, what is it? And then how does it work? And then why does it exist? Kind of in that order. So hey, I'm learning Python. What is Python? It's a programming language, commonly referred to as a scripting language. Great. What can I do with it? Oh, I can do hello world. I can build web apps, bring in something like Django. All right, this is cool. Why does Python exist if Perl exists? Why does Python exist if C exists or Bash exists? And then going back to the history, or Guido van Rossum believing that there needed a better scripting language, why he wanted to get rid of the curly braces, the drawback of getting rid of the curly braces and having tabs versus spaces become a thing. Learning that history helps me understand the decision making. And in many ways, it's almost like you can absorb their experience. So what they've learned in 20 years, a student of the history may be able to grab up in 3 months. And you're getting that additional context. So now that I've gone deep, that whole T-shaped engineer, you get the depth and the breadth. Yeah. And sometimes if you're just patient enough and do that exercise with Python, so when Golang comes out, I ask the same questions. What is Go? What can I do with it? Why does it exist if there's something like Python? And then you go through the same loop. And so to me, I never have a fear of new things because I'm always thinking that there is no way this Istio service mesh is radically different than Nginx. It's just not possible. And now that I have that confidence, lo and behold, it's very similar. Similar protocols are at play, config language is different, implementation is different, but the fundamentals are roughly the same. So the same thing works, I think, for humans. Outside of work, do you pay attention to the things going on in your house? Do you pay attention to the things going on with you? Some people don't pay attention to the emotions that they feel all the time. Like when you're a senior engineer and you're stuck on a problem and you find yourself going to Stack Overflow. How does that actually feel? And so you shouldn't belittle a junior engineer for still going to Stack Overflow. When you interview someone and they can't answer all the trivia, do you give them a low mark and say, there's no way this person could be my teammate because they're not Wikipedia? Knowing good and well that you don't even know the answers to these questions. And to me, that little bit of internal insight, that helps you kind of realize like, and we call that empathy. So empathy is a tool there. And sometimes it just comes from you just paying attention to yourself as you evolve over time, remembering that you were once a junior engineer as well. And again, in your family structures, there's opportunity for learning. And in the team structure, like if you really listen to people, like how's it going? You notice someone is not shipping anything. It's like, man, why is he not shipping anything? How do I find out in the best way that motivates this person? What's the goal here? So to me, I just take it almost as intentional as I do my technical career. So the same blueprint, I need to go through the fundamentals of these things. So there's a lot of people that say, I don't like people, but I love computers. But then they forget that they're using the computer to build things for people. So these things are at odds. You're going to have to reconcile it at some point.
I think that's an amazing insight. You can think about how to really work on working together. As you mentioned earlier, open source communities are a very great place for people to work together. As you were building Kubernetes, how did you take it from being a technology to also being this great community?
So the dope thing about Kubernetes, I'm at the time about 34 years old. So I've been through this before. I was a contributor to Python, Virtual Nth, and PyPy. I was a contributor to Puppet, the configuration management tool. I even built some of my own tools in Golang. Compd comes to mind. And now I'm working at CoreOS. And it's an open source company. Lots of our tools are open source. But I didn't know as much about distributed systems at that time, right? I'm someone who's kind of built things that are in distributed systems, but I didn't have the vocabulary. I couldn't tell you anything about consensus algorithms just 2 years prior, even though we were trying to make sure that all the servers had the same time, because we knew that that caused a problem. And so my first interaction in that world is reading those white papers, like the RAFT paper. So that part of the community, right? You're reading Diego's paper and you're seeing like, wow, there's a way that we can be explicit about consensus. And if you have this one place where we do consensus, then all the other systems can build around it. And that's when I built things like Compd to like give me a configuration management tool that was using the synchronization engine to sync configs without using Puppet, Chef, or Ansible. And then you're learning from the people there, like, wow, this is the person that's working on etcd. Can't believe it's just one person. Can I help? And it turns out you can. All of that operational experience actually applied to this world. And so when Kubernetes comes out, we're already on our path at CoreOS. We have etcd, we have this operating system. We're building our scheduling system called Fleet, which is like Kubernetes layered on top of systemd. And so we were like, hey, we've got this solved. We just got to get these things over the finish line. And then Kubernetes comes out. And it's Red Hat and Google for the most part together. CoreOS, Docker, Mesosphere, all these other players are just kind of on the sidelines. We've all contributed in some way, but indirectly. And the Google team said, hey, we're launching this thing tomorrow. Here's the GitHub repository, and here's the press release. We would like it if you didn't say anything until about 9 a.m. tomorrow. And so I look at this, and so just getting access to the repository, that's that definition of like the open source, like the rawest definition. Here's the source code, here's the license, but there's no instructions. Don't really quite know what it does. And I remember that night spending time getting it to compile and build and then running on top of CoreOS itself. And I spent all night too, because I got until 9 a.m. And when Google launches their press release, I launched this thing like how to run Kubernetes on CoreOS. And so the community shows up and says, hey, you're not the creator of this project. You weren't there in the very beginning, but you're the first person to show us how it works. We now actually can run this thing. And maybe you fixed a few bugs along the way. Maybe you've added some new things along the way. And so that outlet of taking all of my experience and then being able to contribute, I didn't have to be the person who wrote the scheduler. In this case, all of my talents kind of combined into this person who's become now the educator. When I see a bug, I can now fix it and then educate people on how to use it. And so I think the Google team was way more inviting than I ever thought a big company of that size would ever be. All these people from the Borg paper, some of them are sitting there on this project. They're nicer than I thought they would be, because you look at them on this pedestal of like, wow, these are the people who write the white papers. How could I contribute any value sitting next to them? And it turns out you can. And so they were very welcoming. And a lot of people don't know this. Me and 2 other people started KubeCon, Patrick Riley and Joseph Jacks. And we were at the Gopher conference. And we liked the way the Go community was forming, a little bit outside of the Google bubble, into a community of practitioners and people that were so excited to make Go become what it is now today. And we were like, we need the exact same thing for Kubernetes. It was in that exciting phase. Things that don't quite work, lots of things that are missing, but we felt that we as a community can make it happen. And it turns out that's all it takes. 3 people. I think we paid someone like less than $20 to make the original logo for KubeCon. And so we launched the first conference in San Francisco. I think the second one may have been in London. And that community became a really big community. Of course, CNCF has taken it to new heights. But when you go to KubeCon today, you still feel that essence of we can extend this system with our own ideas. And we try to create a world where everyone was welcome. So even though Mesos was number one, I personally never thought about them as like the company to take out. It's like, what can we learn from Mesos in terms of scale? What can we learn from Docker in terms of simplicity? And I remember saying this one thing that really made it all come together to me. Kubernetes would be the thing that I worked my entire career to build if I only knew how, or that was even possible.
Yeah, makes a lot of sense, because you are actually highlighting two things to do to build a community. Think about developer experience, like make it accessible to as much people as you can. And the second one is be welcoming, because community is something which builds up by itself. Like if people can't join you, there will be no community. And this is a thing for a lot of projects, because like you're like, well, that's a great project, how can I join? And there is no way. And yeah, that's it.
I also want to be sure it's clear, because I think a lot of people create too much friction to contribute to these projects. So if you say, focus on developer experience, that's a big title, it's a big word, it's a big discipline. And for people that try to understand that fully before they can contribute, they may be discouraged. Developer experience in this case is, how were you doing things before Kubernetes? What part worked? What part didn't work? If you could change things. So for me, I'm coming as an engineer at Puppet Labs that was building a DSL to manage servers through configuration management, infrastructure as code. In this world, I was so happy to see the code disappear, because I know the drawbacks of trying to use code to describe infrastructure, and infrastructure data is a thing. And so when people say, could you describe Kubernetes? It's like we're moving away from infrastructure as code to infrastructure as data. And a lot of people were confused by that. It's like, there's code somewhere. It's like, yeah, in the control loops. But the contract between what you want to do and what infrastructure does, it's data now. And the experience for me was, you can now build data pipelines. You can have one tool create the object, another tool test the object, another tool scan the object, and then you can just share it with the next person via very simple means. And so I think that experience, your individual experience, your individual taste, is equally as important as the professional discipline of talking to users and getting consensus from a huge group of people. I feel like what open source also brings to the table is, you don't have to get global consensus in the beginning. You can just have the freedom to try something that may not actually work. You almost get this freedom to experiment. You don't have to think about revenue day one. You just got to say, hey, is our collective experience, this thing we want to try, is it worth trying? And you put it out there. And there's this phrase that I like, and I'll end here, is, there are some people who have ideas, and there's some ideas that have people. And when we release an open source project, we give an opportunity for the latter to happen, where people see it and say, we like this, and then we form around it.
Yeah, but speaking about developer experience, I probably meant not something huge, but more like something which makes using your project better. I mean, like creating a manual or fixing README can actually influence developer experience much more than a huge horde of product managers.
Or realizing that you will never do a good job at developer experience. Not you by yourself, not for all developers.
And that's also a thing.
And Kubernetes, when they came out with the extension model, the CRDs, the emission controllers, we realized, as long as we got the data model right, another group could go build a UI. Another team can go figure out tools like Helm charts. And they would all figure out their own developer experience without the compromise of having to pick one. They could all serialize to the same intermediate representation that the system understood. And I think that was the best decision ever made, because I remember OpenStack came out and it was trying to mimic the AWS console in some ways. And sometimes we always feel like, okay, we have to solve this end to end. And I think sometimes the best thing we can do is say, look, we're going to solve it to the part where only we can solve it, but then leave room for a different way of working on top that doesn't compromise the whole system. And I think that's the one thing we got right in the world of Kubernetes.
Sounds great.
Also sounds close to the original Unix philosophy, where you do the one thing you want to do and do it right.
Exactly. I mean, it's so funny. You're reminding people of the Unix philosophy now in this AI gold rush, where people are reinventing, things like MCP and all these things. And I think most people are aware of it, but sometimes a reminder does help.
And with that, thank you so much for being with us here today. We've had an amazing conversation. I think we discussed how basically the future of DevOps kind of comes back to this original Unix philosophy. And with that, if you have better ideas for the future of DevOps, please do leave your ideas down in the comments below. If you do, you enter a chance to win either a certificate for merch or a one-year subscription to GoLand. Thank you so much for watching.
Thank you. Thank you, Kelsey.
Thank you so much.
Thanks for having me.